discussing about GATE 1996 ECE paper, and this is a question related to electronics. Look at the diagram. The given diagram is N-channel MOSFET, where it is used as voltage variable resistor. Determine the expression for the resistance and compute its value when VI is equal to 2 volts. You can neglect the body effect, and the other parameters given are threshold voltage of 1 volt, channel length modulation of lambda 0.3, transconductance parameter beta 40 microampere per volt square. This Kn into W by L can be written as beta itself. Remember that one. Okay. And next, look at this diagram. In this diagram, this is nothing but gate and it is drain. This is source for N channel. Whereas gate and drain are shorted together. Gate and drain are shorted together is nothing but Vi is equal to, you can write it as VGS, which is nothing but VDS. VGS is equal to VDS. Since drain and gate are going to be shorted, so input voltage is nothing but VDS, which is nothing but VGS. Okay. And one more thing is nothing but whenever gate and drain are shorted, at that time the MOSFET will be definitely in saturation region. MOSFET is always will be in saturation whenever gate and drain are shorted. Okay. So that generally the resistance is going to be defined like this: RDS, resistance from drain to source, or it is also called as output resistance, which is nothing but normally it is delta VDS divided by delta ID. But this is a special case where gate and drain are going to be shorted, so that it will be treated as delta VGS divided by delta ID. And we know the current equation in saturation region, ID is equal to beta by 2 into VGS minus VT whole square. This is drain current equation in saturation region, and from this one, okay, differentiate with respect to VGS. Differentiate with respect to VGS this equation 1. By that time what you are getting is this is differentiate this equation. So this can be written as dou ID divided by dou VGS is equal to 2 times of VGS. 2 get cancels. What you will get is nothing but beta times of VGS minus VT. But dou ID by dou VGS is not RDS. RDS is nothing but dou VGS by dou ID. So we can write it as RD is equal to RDS is equal to reciprocal of this value, VGS minus VT. Okay. So here it is, RDS value is going to be this much. It has given 1 by 40 microamperes per volt multiplied by VGS minus VT. VGS is given as 2 and 1 is nothing but VT is 1. So RDS value what you will get is nothing but RDS value is around 25 kilo ohms you will get. RDS value for the given VI is equal to 2 volts. The expression for RDS is 1 by beta times of VGS minus VT. This is the expression for the resistance. Okay. Whereas the value, specific value whenever VI is equal to 2 volts, VI is nothing but VGS, that is given as 2 volts. So 40 microamperes is nothing but beta value, and from that one VGS minus VT is 2 minus 1, and if you calculate RDS value is 25 kilo ohms. But if you consider, that is by considering channel length modulation, okay, by considering channel length modulation effect, that is nothing but lambda. If you consider by considering channel length modulation effect, RDS effective is equal to lambda times of RDS. So lambda is nothing but 0.3 multiplied by 25 kilo ohms, which is nothing but 25 into 375, 7.5 kilo ohms is nothing but actual resistance whenever VI is equal to 2 volts, and that too channel length modulation is considered. considered. If you don't consider, the RDS value is 25 kilo ohms. Channel length modulation is nothing but, if you don't consider the channel length modulation, the drain current is constant in saturation region. If you consider the channel length modulation, at the time drain current slightly increases in saturation region as VDS increases. Okay, so this is the right answer, 7.5 kilo ohms. Thank you.